2021 Leaving Cert question 3. Diagram shows a cuboid, dimensions x, y, z. The areas in centimeters squared of the faces are shown. So this one here is x times z is equal to 2 root 2. We'll do it up here. X times z is equal to 2 root 2. What else have we got here? We have this big long one here. That's y times x. Y times x. Not y times z. Y times x is equal to 4 root 3. And lastly, we have this big face here. The 8 root 6 is y times z. Y times z is equal to 8 root 6. So quite a few different ways to simplify this down. So let's have a look here. We have yz. So if I can get y on its own and z on its own, what can we say here? Z is equal to 2 root 2 over x. And we can say that y is equal to 4 root 3 over x. So zy becomes 2 root 2 over x times 4 root 3 over x. The top is going to become 8 root 6. Your calculator will do it for you if you're not brilliant at thirds, but 8 root 6 over x squared has to be equal to yz, which is also 8 root 6. So that has to be equal to 8 root 6. And for that to be equal to 8 root 6, x squared would have to be equal to 1. And x in this case would just have to be positive. X is equal to 1. We're asked to find the volume, so we're looking for x, y, z. Well, if x is equal to 1, z is just equal to 2 root 2, and y is equal to 4 root 3. So we just have 2 root 2 by 4 root 3 by 1, which is equal to 8 root 6. And I think they chose this one maybe to confuse people. Good students might go, well, the volume 8 root 6 and the area is only 8 root 6, but if one of the sides is 1, the volume will be the same as that biggest side. It's like a prism, just with one depth, which is your area will be the same as the volume. So 8 root 6 cm cubed is the volume of this shape. Yep, this is a real question. It says given that f of x is equal to 3x squared plus 8x minus 35, find two roots. So factorizing a quadratic at Leaving Cert higher level. 3x by x is 3x squared. 35 would normally be 7 by 5. So let's just check that one. Where can we put a 7 and a 5 here to get this to work? A 7 over here would give me 21. That's not going to work. A 7 here would give me 7. You can see here that's going to work. And 15, that can give me 8. I want plus 8x, so plus 15x to 3 by the 5 minus 7. So the roots are x is equal to 7 over 3 or minus 5. Can you believe it? So hence or otherwise solve this equation. 3 to the power of 2m plus 1 equals 35 minus 8 by 3 to the power of m. Now you should have, if you didn't recognize that that was the same as that in some form. And this is just one of these index equations. So we're going to have 3 to the power of 2m plus 1. I'll just bring them all to the same side. Plus 8 times 3 to the power of m, and that will be minus 35 equals naught, same as the top. So you can say here that, well, if we didn't have the top, we'd say let y equal 3 to the power of m. Therefore we have 3 by 3 to the power of m by 3 to the power of m plus 8 by 3 to the power of m minus 35 equals naught. So we'd have 3y squared as above plus 8y minus 35. So that's the basis of these questions, these index equations. So we've already solved here for x, and y will be the same. So we can't have a negative with these index equations. So we're going to say here that y is equal to, it's going to be 7 over 3 is the solution. So we can say that 3 to the power of m is equal to 7 over 3. I'm going to bring the 3's together here. There's quite a few ways to solve this. We want just m on its own here. M is equal to this log here. So let's say 3 by 3 to the power of m. We could separate this division here into logs straight away, but if we say that that's equal to 7, Then we can say 3 to the power of n plus 1 is equal to the 7. So you'd have n plus 1 by the log of 3, getting the log of both sides, is equal to the log of 7. The log even of 7. Change that to a recognizable g. The log of 7. And if I divide by the log of 3, I'm going to get n plus 1 is equal to the log of 7 divided by the log of 3. So m is equal to the log of 7 over the log of 3 minus 1. And you can see up here we want it as the log of p to the base 3. So that's going to be, let the 3 out, m is going to be equal to the log of 7 to the base 3 minus 1. That's the answer to this part. Up here we could have got the log of both sides straight away. It might work out slightly quicker to do m by the log of 3 is equal to the log of 7 over 3, but it works out the same. So this is my solution to question 3.